Hey, hey guys, what's happening? Good to see you guys. It's been a minute. Been quite a good minute, I guess. Yeah. So, hope everybody's doing good, doing good. What I want to say, guys, I'm going to give you a short little explanation on what and where I've been. I'm not going to go into detail. It's just not. It's too much. I've had some really rough things happen. So I will again, like I said, I'll go into that here a little bit. But yeah. So it's good to see everybody. I'm gonna say hi to everybody real quick. But we do have some space weather, and it's a good time for me to get back on the horse here. And before I forget, Trinity, red pill, blue pill, hi ho, Kermit the Frog here. I think we are scheduled for she's going to come over here tomorrow. We do a live stream. She's going to be a guest here. So come tune in for that. I will let you guys know for sure, a little bit more on what's going on with that, as long as her schedule's still lining up with mine, and we're trying to make that happen, and we're going to make that happen this week sometime. Hopefully tomorrow, as long as she's good with all that. But yeah, so we've had some space weather, and yeah. Oh yeah, by the way, I forgot to mention, the super chats and stuff are now turned on. I got all that turned on now. So I'm not even gonna. I hate even mention. I feel uncomfortable even mention it. But if you guys want to, you can. It's there. Don't feel obligated. Please don't. If you don't feel, just don't. And the main reason I did that is I'm planning on starting up memberships, and I'm working on that. And it shouldn't take me very long to get those memberships started up. And the reason for that is there's some things happening here on the platform that we can't really. How can I say this? In February, there's some things that are changing, and I don't want to use the word. They're going to be scrutinizing a lot of what we say a lot more. Okay, that's just what's going to happen. It just is. So, that is what it is. There's nothing I can do about it. But I do want to start up memberships so we can have a place to go and go there. I probably will not monetize the membership streams. I might monetize them, but if they start getting like demonetized for the conversation that we're having in the membership streams, that I'll just have to just hit the demonetization on that. It's not a big deal. Again. But I do have some pretty cool things planned for the memberships, and I'm gonna get that going so we can have some fun with that. None of the content that you currently get here is going to change, just so you know. Okay, it's just not going to change. I'm going to continue to do what I do here. I'm just going to add some extra stuff, and that's what I want to do for the membership part of it. But again, guys, the super chat thing is there, so if you guys. It's there. So I just wanted to point it out. It's just something new there. And once I get the memberships going, I think that'll be a good way to get us all into a space where we can talk about certain things or what have you. So, and also, guys, there are still going to be some subjects that I can't still talk about over there because some of that breaks terms of service. Some of the stuff that they're doing is not something that we've had to deal with before. You guys can look into it yourself. I'm not going to say it here because, it doesn't do anything. It ain't going to do nothing but disrupt things. So, anyway, guys, we're going to go do this. And also, I got to get the widget back onto my OBS so I took it off to highlight messages. So, anybody that does super chat or whatever, I'll be able to highlight it and any of that stuff so we can, do all that. But, so, am I 5 for 5? I forgot to even ask that. Back at you, Piper. Back at you. Hey, Ripper, good to see you. Hey, Daryl. Hey, everybody. Hey, Miss B, good to see you. Haven't seen you in a minute. Haven't seen you in a minute. And again, guys, go check out all the channels I always say. And I might mention them a little bit later. But for this stream, I need to get back on the horse. So we're going to go do this. All right. Thank you, Piper. All right. Here we go. So we've got a lot of eruptions on the sun. So what I'm going to do, I'm just going to let you guys see this for a second. This is NOAA. This is NOAA Space Weather Prediction Center. And what you're going to see, G1, G2, G1, G2, G1. Excuse me, guys. That's part of the reason why I ain't been here. I got really sick. So, anyway, my whole family did. We're still getting over it. So, it just is what it is. But anyway, you got this over here, G1, G2, G1, G2, and it's going to change. It just will. That's what's going to happen. We've got more eruptions happening as I was going up for this live stream. You know, as I was getting ready for this live stream, there were more eruptions happening. And these are big enough eruptions, and I want you guys to understand what we're seeing here. You guys see how the flare activity it's active, but it's not strong? These are not strong solar flares. Okay, so what this is telling us when we go over here and look at this helps us understand the difference between a flare and geomagnetic storms. Okay? Between a CME. A flare and a CME. So, you're getting plasma erupted. And where's it coming from? Well, it can be coming from these small little flares, but what we're seeing right now are filaments just snapping off left and right. Okay, and, well, as you can see right here on LASCO C3, this is the satellite. It's on SOHO. It's about 1 million miles closer to the sun than what we are. And it's from our perspective. It's out in front of us. So what are we looking at here? Huh? Well, what we're looking at, that's another eruption that just happened a few hours ago. And this one here, I'm going to show it to you on a different one in just a second. But there are a bunch of eruptions, and a lot of them are coming at us. So we are going to get geomagnetic storms. I'm timid to say exactly how strong. Okay? It just is what it is. So, but anyway, as we get going here, I'm going to go ahead and just jump over to seeds, and that's that same eruption right there. So I'm going to hit start, and you're going to get to see, this is just this last eruption. Well, it's not the current one, it's erupting now. This is one before. So I don't even know where the most current eruption's happening at yet. I haven't seen it yet. It was, like I said, it was happening as I was getting ready for this live stream. So, yeah. So, anyway, as you're looking at that, it looks intense, right? We don't typically see these kind of perspectives, I guess you could say. Because when you look at it, you see how bright it is on the red view? It's probably just the angle of which the image is getting taken here. But when you see black and white over here, you can think of it kind of, I guess, in the terms of hot and cold. It's all hot, obviously, but one's colder than the other. Anyway, that's how the imager picks it up, the coronagraph. So, as you can see here, it's pretty photogenic, and it doesn't mean that it's any stronger than anything else. Okay, it can point to a stronger one, depending on what it looks like. But as you can see, that is holding on pretty good there. I mean, it's pretty distinctive. That's a lot of plasma. And when we see plasma like that, that usually is not just a little bit of a poof from the sun. This is kind of what magnetic filaments look like when they flop off the sun like that. Okay, so let me just start that. I'll slow it down. We can just look at this for a second. I am going to take you back a couple days because I want to show you there's at least 3 CMEs going to hit us. How can I say that? Well, all of the models are saying that. Now, one of them's kind of a glancing blow. Well, actually, 2 of them, not really glancing, kind of a side blow. But one of them does look to be coming like almost right at us. So, and again, you can tell these things aren't little. These aren't like, just little jets shooting off. These are decent size. Okay. So anyway, what we'll do, let's go back over here first. I do want to go to, let's just back it up to the 20th. How about that? Okay, so you start seeing these eruptions. Actually, I'm going to go back one more day, back to the 19th. I think it started late in the day on the 19th. And you can see one here on the northern part, but watch at the end there. Did you guys see that? You probably didn't, because most people that don't do what I do here, anybody that reports space weather is probably seeing it right away. So let me explain to you what I'm talking about here. That's an eruption, right? But did you see that little bit of a cloud puff out around this occulter disk? Remember, this is from our perspective, and that's a physical disk on the imager. Okay? What does that mean? Well, it's just a physical disk on the imager. It's blocking the main part of the sun, light. If it wasn't there, we wouldn't be able to get an image at all. So I'm going to pause it, and I'm going to back it up here a little bit because, okay, so you get this, we always see these big ones, right? We see the ones that are kind of firing above, to the side, or below the occulter disk. But when something's coming right at you and you got a black disk in front of your face, you can't see what's right behind it, right? So we can't tell if anything's coming at us or even going directly behind us, unless, or directly the opposite way, 180 degrees off the backside, unless we see things poke around this occulter disk, right? And we call this a halo eruption because it looks like a halo in the most dramatic effects that we see. And again, it's just effects. It's a visual effect from the imager. So you guys see this? I know it's kind of probably hard. I'm not sure if you can or not, but that was one of them that's coming right at us. It's a full halo. And I'm sure you can kind of see it now. It kind of looks like a flower or a burst, a starburst. See what I'm saying there, guys? Hopefully you guys can see that. So, anyway, let's, excuse me. Frag out, what's up? Need better friends? What are you talking about, bud? I got a lot of good friends here. Anyway, so you see that, and it's, yeah. So it is, that's a halo. Next day, 20th. Another one. You see how that one was kind of a halo also? See all these eruptions, guys? I mean, this isn't going to stop right now. This is what we're seeing. That was on the 20th right there. Let's go to the 21st. Another big one. Okay? So we're getting these, and they're coming our direction. I think there was one or two going kind of off the backside a little bit. But I'm going to pause it here, too, when we get to that little visual glitch here in the images. Right there. When you see stuff like this, okay, what that is, that's sometimes it's the light reflecting off the inside of the imager. Because when you look at the camera, if you guys were to go look at the specs, it's a tube. And they have little dampers in there to control the amount of light that's in there. So when you see these things that look like perfectly rounded and have that little... If I was to show you, and I probably will, I have before, what the imager looks like, it looks almost exactly like this. Okay? So what that is, it's just bouncing around. But also, highly charged particles can show up in this kind of format also. Typically not rounded, kind of smooth. Usually they're just like streaks going across the imager, right? So I tend to think, because you can see how this got real bright, so it probably got flooded with light, and it bounced around inside there, and the imager couldn't handle it. That's the main reason why this disc is there. It's a really good way to show you guys that. But anyway, I wanted to show you guys that because it wasn't really, it'll show up on here as the imager thinks it's like a CME. But it's not. It's just getting flooded with light. It's confused. So anyway, Because when you see the blue and the yellow, the blue and the red lines and stuff here, it's trying to outline the CME where it's at. So when it sees something so dramatic like that, it can't handle it. So that's what you're seeing there. So let's go to today, the 22nd. And happy birthday to my nephew. My nephew, I doubt if he's watching. He's a young kid, but I just want to say happy birthday to my nephew. I'm not going to use his name for obvious reasons. But love you, buddy. Anyway, so as we get going. Oh, it's okay, Frag. It's good. We're all good, bud. I was just curious about that. It's all good, man. For real. I tend to think I got some pretty good friends hanging around. All right. So, now, as we're looking at this is the 304. This is SDO, okay? This is a satellite that hangs out in geosynchronistic orbit. I've shown you guys this multiple times. It does that little figure 8 pattern I've shown you guys. And it's always looking at the sun. Well, right now we're actually in eclipse season for SDO. What that means is the satellite, the Earth will actually pass between the satellite and the sun. And the sun will actually it'll go dark here. And I'll show it to you when it gets here. But I'm going to play this, and I want you guys to look at the dark lines and how they're ripping off the sun here. So let's just watch it here for a minute. It's pretty impressive, to be honest with you. And I know it might not look too all dramatic on this particular viewpoint from this angstrom of light, which is 304. This is ionized helium. That's what you're looking at here. It's looking at a specific gas. We can't see that angstrom with our eyes. You see that last one blow off right there? And then one over here. So these things are just erupting all over the place. One thing I'm not seeing is massive flares. Now, we did have one come out of this sunspot area, right? But this filament down here that ripped off, it didn't look like there was any kind of a filament, any kind of a sunspot with that. You see how that kind of just opened up like what we call a canyon of fire on the sun? Because it did. It literally ripped the plasma. Just whoop, ripped it right open like a big canyon. So that's what's happening there. And that's why that one image I showed you guys looks so dramatic on Soho. So anyway, so you're seeing that rip off right there, right? But yeah, so, and look at all of it. It's multiple, and these are mostly filaments, guys. These are not like blasts from sunspots from big flares. I have to keep saying that because I want people to understand that flare and CME is not the only things we see. But you can definitely see it, and it's a good way to show people because it gets them to understand what's actually happening here. So when you see those dark shadows, that's what I'm talking about. The filaments is kind of hanging around there. So I'm going to back this up right here. I want to show you the eclipse. Okay, see how it goes dark for just a second? Now watch what happens when I can slow it down. See how you still see a peak of the sun right there? Back it up another image, you see the full sun. Now watch what it does when it goes off the other direction. See? So that's exactly what's happening there. Okay? The satellite is just in a position that the Earth, I guess you could call it the horizon of the Earth or just the limb of the Earth or what have you. But yeah. So I wanted to show you guys that because inevitably somebody's going to come out here and tell you that there's 5 million different things flying in front of it and none of it's true. Just saying. You know how I know none of it's true? Because you can go to SDO, you can go to the website, and they will tell you exactly when this is going to happen. It's called eclipse season for SDO. That's what they actually call it. And they can tell you exactly what days, how long it's going to last, all of that. All that information is there. So it's not like they're... it's just that this is just exactly what this is. So, you know, You know, and again, I'm not gonna like get on people that don't believe that. They think something crazy is going on. It's your right to believe that kind of stuff. It really is. But for me, this is what it looks like to me. So that's what I'm saying. Now, also, every once in a while, you'll get the moon will actually go in front of this thing, not the Earth. You'll see it, and it looks, yeah. You know, we also see the reverse eclipse. What I mean by that, the eclipse will start to happen, the Earth will get in front of it, and then because of its positioning and the way the satellite and the Earth are moving, it'll actually look like it stops, and then it'll go back the other direction. That really freaks people out. Every time that happens, you can bet your butt I'm going to come out here and explain why that happens. Because it does look very crazy. Okay? So when people see that, that's definitely what I always address that when that happens. Because it does look like something crazy's happening. I can see how, because I used to think it was until I understood what I was looking at. But let me go ahead and zoom in here a little bit for you guys too. Okay? I'm going to go down here. Now watch the dark shadow. Watch how big these filaments are. There was one big one. See how you see dark shadows even over here? And they're just blowing off one right after the other. Watch this canyon of fire open up right here. It's getting ready to happen right here. I'm really hammering this home right here on this because, see that? That just shows you the violent nature of what's actually happening. You know, these are massive eruptions, okay, in the sense of the size of them. Now, whether or not they hit us and whether or not we get huge geomagnetic storms out of this, I really can't say. I can speculate and I can give you an educated guess, a somewhat educated guess, just for me looking at this for years now, and studying it as much as I could. But as we're looking at this, I want you guys to understand that, right? So let me go here. Now this is, I actually recorded this because I'm going to show you the first two that are coming at Earth. What you're looking at is, this is the NASA model. And this is the sun from the top down, our inner solar system. That's the sun, that's the Earth, right? This is a side cut. Okay, it lets us know north-south what direction the CME's headed. This one here is our orbital line, which is a circle on this one, right? But they stretch it out. And it gives us 3 axis points to look at, which lets us understand what direction it's going. Because these are all two-dimensional things trying to represent something that's three-dimensional, right? So, anyway, now, so what it does is allows us to get a good idea if it's really going to hit or not. So I'm going to play this, and I slowed it down. That was the first one. And I'll let you know when it switches to the other one. But that's definitely hitting us on all 3, and I'm going to pause it when it does here. Okay? So, yeah, you can see how it's hitting us on all 3 axis points. Now, so this is NASA's model. This is NASA's version of this model. It's the same model, but they take different data points and they plug them in. Not different data. They use the same data, right? But their models they're able to adjust what they take into consideration more, such as speed, power, direction, all that stuff, right? So they're able to adjust it for what they think is the most appropriate for their model. Now, NOAA and NASA will never exactly match up. It's impossible. That can't happen because their models are different. They take you'll see the same images, but they're going to be different. They're going to look a little different. They're going to tell you that the CME is going a little bit more this way, or it's going to miss altogether. I've seen this one showing us taking us a direct hit, and NOAA saying it ain't going to hit us at all. And then one time it'll hit, and the next time it won't. So they've both been wrong. So that's what I'm trying to say. So when you see them and then we check them both out, what that lets us know is it gives us a better chance of understanding if it's going to hit if both the models are agreeing. So that is the first one. Now here comes the second one, I believe. Yep, here's the second one. Sorry I got dim on you there. But that is what it is. Now I'm going to pause it right there because this is a glancing blow. This is what I call a glancing blow. because it's just like a boat going through water. All right. So it's pushing things, and you're going to get a wake that comes out this direction on both sides, right? Like if anybody's ever been on a lake or even in the ocean, they have those no wake zones where you can't get close to the shore moving at certain speeds because it adds too much wake. It goes into the beach, and it can mess with people, boats, and everything else, right? This is kind of the same thing here, all right? So it's just kind of pushing things. And so as I push play here, you're going to see, and I'll pause it again when it gets back around to where it's kind of going to be almost hitting us, I guess. So right there, now you can see how the wake is just kind of, it's close, right? Now, sometimes these glancing blows can actually hit us harder than a direct hit, depending upon what our magnetosphere is doing at the time. And when I'm talking about our magnetosphere, it's our magnetic field. Okay, so I'm just going to push play here. We'll watch it here for a second. That's the first two. Okay, I'm going to take you guys to the most current, the most current NASA model here. Let me pull it up. Sorry, I don't run this one because it tends to slow everything down. Oh man, they took it off already because that other CME. So this one only shows you one CME at a time. Anyway, there was a third one that was coming right at us. Okay? So, yeah. We're going to get 3 at least. Noah's model does not do that. Noah's model will show you all of them. Okay? So, what we'll do, we'll go over here, and we'll see what Noah's model looks like. How about that? So, what you're looking at here, it doesn't look like it's going to show us the third one either. It might. So, there's the first couple. You see all that, guys? There's the third one, probably. See how that kind of popped off, and it's not going to get here till right there? But it is a hit. Now, you know, whether these things actually hit us or not, again, I'm not comfortable just saying 100%. But it does look as though the models are agreeing. Okay? And if these happen in succession like this, I don't know if we're going to just stay at a G1 or a G2. I really think it can get higher. You know, especially with multiple eruptions, you can see it's very active. Okay? They're probably going to end up changing this a little bit. Okay? So when's it supposed to start? Well, it's supposed to start later on today. Actually, here in a few hours. Okay? So it actually might be starting now. You see this? This is the KP. This is what we look at. This is the gauge that we use. Right? And when we use these gauges, what we're going to look at here is the KP to be able to distinguish which, how strong the geomagnetic storm is. So a KP of 5 will directly say it's a G1 storm. Now G1s aren't typically all that big of a deal. Okay? When we're talking about, I know everybody says, you know, they always want to say grid down, that kind of thing. You're talking G5 or bigger, way bigger than the G5. If we're going to go grid down, we're probably going to be talking, yeah, I'm not even going to speculate. So, but it would be a G5 at the very least. Okay. And with that being said, yeah, I don't even know what else to say on that, because it's normal for somebody to see these big eruptions thinking, oh my God, we're going to see grid down. It's a normal thing, okay? Most people think that right away. But once you understand, and that's why I'm here, I want people to have a good idea of what's actually happening. I don't ever want to come out here and lead you guys the wrong direction. So oftentimes, sometimes I do myself and frankly, you guys a disservice by downplaying things a little bit than what I think they're going to be. Because I don't want to scare people. And so I just try to make people aware. Usually what I'll do is I'll give you a range of the way that it could go. And I've been pretty accurate with my range. I've been wrong before, and then when I am, I come out and tell you. I was wrong a lot, especially at the beginning. So, anyway. So I do want to point this out too. The solar proton flux, we almost got into a radiation storm. And it was directly related to all these eruptions. Okay, protons have mass, right? So it takes them longer to get here than X-ray. X-ray is traveling at the speed of light. It's here and gone. Well, I don't want to say gone. It's here in 8 minutes. Okay. The effects from a flare, as far as hanging around in our atmosphere and those kinds of things, doesn't last very long. We get radio blackouts from the X-ray. Okay. And they measure them in R1 all the way up to R5. So when you see an M-class flare, which is just under X, you can expect an R1 radio blackout on the day side of the sun. Of the Earth, I'm sorry. So whatever daytime when that happens, because it gets here in 8 minutes, it's almost immediate. In the terms of space, that is pretty much immediate, okay? But notice how the protons have a little bit of a lull. And then there's a reason for that. They have mass, right? So when we get blasted with protons, that's a radiation storm. Now in S1, their models will even tell you in S1 is absolutely nothing to worry about. We won't even see no effects on the surface. Okay? Now when we get into an S1, you can pretty much bet I'm going to come out and tell you about it. It might be the only thing I'm talking about. Because it is space weather and it is space weather newsworthy. All right? But we need to talk about that because that means that there was eruptions coming from the sun. And as we move forward here, if you look at the S2, as you move up, yeah. So if we get like to an S5, I'm not going to go into what can happen with those kinds of things because we're not dealing with that right now. But as you can tell, so as we got this hanging around, if we get more eruptions, it could go back up. Okay? And I tend to think it probably will if we continue to get eruptions. So, but anyway, with the KP is what I want to talk about mainly right now. Because the flares aren't really an issue right this second. What we're looking at is plasma from filaments. Those are where those eruptions are coming from, guys. Okay, so when they flick out, and with filaments, and when I say flick out, let me do this as I got this up here. This is the same satellite I just showed you over here at Seeds. This one. Okay. Matter of fact, I'll just use this model. How about that? Okay, so when I say flick out, I'm going to show you what I mean. See how it's blasted out there like that? But notice how it tends to have a loop here on the end, a complete loop. And it does one of those. It kind of rips off, and then the filament will snap in the middle typically. It'll snap somewhere on the filament itself, and it's just like an old incandescent light bulb. Okay, an incandescent light bulb had a filament, which is nothing more than a magnetic connection line, basically, is what I'm going to use. It's a piece of metal, and they coil it. Why do they coil it? You ever ask yourself that? The reason they coil that, because they're adding extra friction. That's where the light comes from. The resistance there. So it makes it glow. That's where you get the light from an incandescent light bulb. Passing electricity through that resisted part of the magnetic connection line. So when that breaks, what happens to your bulb? It blows out, right? That's exactly what's happening here. This filament, when it snaps, typically they'll snap closer to the middle. And then when they do, they'll flick out in two different directions. That's why you got this. That's why it opens up like that. Now, you also see other eruptions come from like impulsive stuff, like flares. And they'll look very similar, but typically with a big eruption like coming from a flare, it's more of a solid line. More of a consistent like haze look. When you get the filaments, you'll start seeing these little lines in here. Okay? So that's I just point that out so anybody that wants to go look at this model for themselves can. It just is what it is. Okay, so okay. I'm lost there, Mike. Gotta read your comment there a little bit. I'm trying to keep up with the chat a little bit. I don't typically. I try with my mom. Hey, Trinity, good to see you, girl. This is the first time I'm seeing you in there. Anna, what's up? Menacing, good to see you. Rippers in the hizzy. Okay. Ilea would be here. I just seen if you're listening, Ilea, at any time here, I got your text. So cool. Family first, always. 100% always. None of this stuff matters over family. Ever. Remember that, okay? Oh, okay. Okay, okay. I'm with you now, one. Okay. All right. Now, so with that filament, blowing off like that, let's go take a look at, okay, so I want to talk about the BZ real quick. We look for -6. This is solar wind data, guys. This is space weather. This is the data points that those models take in consideration that I just showed you guys. So when we look at our magnetic field, we look at the magnetic polarity of it, which kind of gives us a sense of direction of which way it's pointing, kind of thing. So they look for -6 on that, okay? I'm not going to go into big detail here, but here on the discovered page, you will see anytime it's in -6, it'll show up kind of this purple pink color. Okay? What that means is that we're in a negative position, and because we're in that position, CMEs, any kind of space weather, typically will be drawn into our system easier. Okay, so to get bigger hits, typically this needs to be at least -6. Okay? Now, we've had geomagnetic storms hit that didn't get to -6. Absolutely, we have. But that's just a threshold that they kind of rule of thumb that they've set. So when we see the -6, we definitely take notice. And that was actually -10. So the further negative this goes, the more stuff that gets drawn in. I've seen this thing -30. I think even -40 one time, if I'm correct. When that's happening, I mean, anything that's coming at us is going to get drawn in. But notice what happened like really, really quick, like, whoop, right back up the other direction. Okay, so this has to hang out here typically for a second for that stuff to happen. Oh, thank you, Trinity. Appreciate you, girl. So much. Thank you. Hey, that's my first one. Thank you. You are the best. Thanks, girl. I appreciate you. Man, I didn't know how that would feel. Just to be honest with you guys. Anybody that's been with me for a minute knows that I really didn't want to monetize. And I finally did, and people have been pushing me to do it for a long time. A couple years back, I put a PayPal link out because people were asking, and I even quit doing that. But I do think that I want to get membership started, and just like anybody else, guys, I have a family I have to take care of, and frankly, this is a second job. This is a job. So, but don't ever feel obligated. But thank you so much. Appreciate you, Trinity. All right, guys. So, as we get moving, I'm going to go back here. Sorry, I got sidetracked there. Okay, so, and I did mention you coming on tomorrow. I'm not sure if we'll talk in the background about that. I'm still okay with that. If you don't have the time, we can move it a little bit. It's not a big deal. But we can talk about that in the background. So, but I did mention it. So, guys, come back tomorrow or even later on tonight. I might do another stream later on to give you guys an update. If we get into big geomagnetic storms, I will be here. Okay? That's something I always do, even if it's only for 10 minutes. If we get into big stuff, I'm going to be here. So, just know that. Anyway, okay, so we got -6 here. And when we get -6, that's when stuff's drawn in. Now, this next line is the phi angle. That's the solar wind. We're always getting solar wind. The sun is always producing solar wind. It's charged particles getting here on a magnetic connection line. What does that mean? Well, that just means exactly what I said. We're connected to the sun magnetically. Everything in our solar system is connected to the sun. If you were out in space, butt naked, your left butt cheek would be connected to the sun. Promise. Okay? If anything that has magnetism, you're connected. So what happens is the charged particles travel on that line. It's plasma. Okay? What's plasma? And I know I'm going into some detail here, but I think people need to understand this. Plasma is the fourth state of matter, right? You got solid, liquid, gas, and most people stop there. There's a fourth. There's plasma. That's nothing more than charged gas. It's the third state of matter with the charge on it, negative, positive. So with that being said, if you think magnetism kind of in the sense of electricity, negative is drawn to positive. That's why this phi angle matters. Okay, so if the particles are negative coming off the sun and we're in a positive orientation with the solar wind, it's going to get here. It's going to get here faster. This is what happens. If it's the other way, we're kind of slowing things down. We're adding extra friction there, so things kind of move slower, right? So anyway, now yes, 100%, Anna. That's 100%, guys. Yeah, I agree with that, guys. Good. Yeah, it's a good. I kind of hit on that, so thank you for talking about that, guys. I appreciate it. I 100%. Yes, get over and check out Tommy on the lifeboat. Big things happening over there. Get your butts over there. Big things. Awesome, cool stuff. Okay, just so you know. And okay, so get over and check out Johnny also. Johnny Scoville, Chase the Heat. He's had a couple of streaming service episodes, guys. He's part of another. Yeah, go check it out. Go over to Lifeboat, and Tommy talked about that a little bit today. Well, yeah, so go over there and check that out. But it's part of another special that Johnny's a part of. He's the GOAT of eating peppers, guys. Just so you know. That's why his pseudo name is Scoville. You know. So anyway, this is density. This is plasma density, right? So what are we looking at here? Well, we're looking at basically an increased amount of them. Okay, that's really what you're looking at. So when things get dense, the speed will go down typically. But when these start falling the same direction, because this is speed. Now, normal density is 3. But I don't hold too much stock in that because I've seen us get geomagnetic storms with the density being 2. And then I've seen us be at 20 on the density and not get anything at all. Why? Because of this. The BZ. The -6. I'm telling you guys, that's really what determines a lot of how something hits Earth. Okay? Now, with the speed, that affects things too. Now, I will say this. On bigger eruptions from the sun, that can overcome this -6 threshold. Okay? So if it's a massive eruption off the sun, and it's coming directly at us, and our BZ really isn't in a position to really draw it in, it can overcome that and still give us a good hard hit. Okay? So in some levels, the bigger ones, it matters, but it doesn't matter as much. Okay? But anyway, so then you got speed. 300 to 500 kilometers per second is what we would typically look for what we would call normal. But again, guys, and something else here, I want to say that, our magnetic field is weakening. There is no question about it. That is the data. That's what everybody will tell you on both sides. Whether you are wholeheartedly with mainstream or you're way over here in the alternative beliefs and all that. Yeah, I look at all of it. So that's just what I do here. I don't, you guys know how I do things. I don't exclude anybody or anybody's thought process. That's something I will never do. And I hope you guys kind of appreciate that. But anyway, 300 to 500 is what we look for. So anything outside of that, especially if it's higher, the speed itself, if our density is real low, think about what I'm saying here. And actually, as I'm saying this, I'm going to bring up a different model for you guys because I want you guys to see this too. Where's it at? Okay, here they are. This is our magnetosphere model. Sun's off to the left. All right. So things are moving from the sun towards Earth. It's a good way to show you what our magnetic field's doing. This is our magnetopause. Let me pause these because anybody that streams, if you're ever showing models or showing videos and things, while you're showing them, shut all of them, pause them. Because if they're trying to play, it's going to kill your freaking bandwidth. That's something I had to learn. Anyway, so I don't know why this one isn't up there. There it goes. Okay, so this is speed only. Okay, showing you nothing but the speed of the particles. See how you're getting waves coming in? All right, you see our bow shock kind of reaching out further and further? It's sensing stuff come at us, okay? So it's trying to get out there ahead of it. It's getting drawn to it. And so what we're saying here is that, and then when we get hit, it'll compress back down. See that? See how that happens? And a lot of times we'll get what we call compression, which is the hit, and then we get rapid expansion after that hit. And let me take you back here to this one. See how we're getting hit? Now watch. See how it just keeps pushing back out? That's what happens. We get compressed and then it pushes back out. That's exactly what we would expect to see. So we are taking some sort of a geomagnetic hit right now. Now, as I move forward here with the density, notice that we see the bow shock here on the speed, right? That the bow shock is the point where solar wind meets our magnetic field. First point of contact. Okay? Do you see that anywhere here on the density? If it is here, it's in a different spot, right? Well, that's not the case. Okay? And I'm going to take this back to the beginning so you guys can see this. We'll get a proper... See how it's kind of right here? You see how it's kind of got like what we call wings kind of falling out there? You don't see that here, do you? Why? See that? Right there? That will match this. Why is that? Because this is density. So if the particles are the same density on this side of the bow shock as it is on the other, it will look exactly the same, and it will appear as if our bow shock is not there. So when you hear somebody tell you the bow shock is down, you need to run from that channel. Or at least try to help out and correct that, because it's not the case. If our bow shock was down, that means our magnetic field is not there at all. That's what that would mean. Or we would be having no solar wind at all. What does that mean? That means the sun's not there. So both is really bad for, it makes for a really bad day here on Earth if that happens. Just so you know. So, as we move forward, let me go forward here. And you're seeing the lower dense particles are white, okay? But I just wanted to show you guys that. Now, everybody understands magnetic pressure. Everybody understands pressure, right? You can just grab your arm and squeeze. That's pressure. That's a very simple way to explain that. But this is magnetic pressure. This is causing pressure on our magnetic field. This is what happens. See that? So, when we come over here and we look at this one and it's like blaring red, that means we have a whole lot of stuff hanging around. But you'll oftentimes see this kind of a signature. And people ask me why. Well, we get reconnection points on the backside. Remember I said it's all magnetic, right? So when we get hit, our bow shock pushes it around here. It will, once it gets over here, then our magnetic field will actually kind of bring it in from the backside because the polarity changes right there. It gets drawn to the other polarity on the other side of the planet here. And it'll get sucked in like that. Okay? So oftentimes we'll see the magnetic pressure be a lot heavier on the backside than what we see on the front. Not always, but sometimes. Okay? So with that being said, I just wanted to explain that. So that helps you guys understand what's going on with our magnetic field. All right? But I did want to show you that. Now, already showed you guys that. Now, I do want to touch on the asteroid thing, okay? First and foremost, what I'm going to tell you is, okay, let's go to the 20th. This is Space Weather News, spaceweather.com, okay? Go over and give Dr. Tony Phillips some love. His stuff is in my comment section, in my description box, guys, okay? So with that being said, let me go here. Let's go to the 21st. And he's talking about it here. Okay? It was a new asteroid. I'm not even going to try to butcher that name. Christianan or Chris. Yeah. Christitian. I'm not even going to try it. I don't want to butcher somebody's name, discovered it. Okay, it's a new asteroid, and Luca Buzzi managed to photograph it. So, guys, go give them some love. They get full credit for all this. This is something they did. Please go click on their stuff and look at it. Okay, and there's your meteor right there. I know it doesn't look impressive, but it actually is, guys. To be able to catch that, and it did, and most of it burnt up before it hit, if not all of it. But it was an asteroid. I think they said it was like a meter in size, which is substantial. How would you like a meter sized rock falling through your roof? Wouldn't be very fun, would it? But no, it didn't damage anything or anything like that. But I did want to touch on it, and it is, we haven't really had a story like that in a while. Okay, but I do want to scroll down here because I want to show you guys what Dr. Tony Phillips has done. He's got nothing but respect for me on anything that he does, really. He just does, this website's just really cool. But anyway, also, guys, go check out the Carrington app, over on your Play stores or whatever. Whatever Play Store you have, Apple, Google, whatever you do. Go over and check out the Carrington app. It's a really good way to keep up to date, real time. They show you some of the models. Todd does a really good job running that app. So just so you know. But this is a near-Earth object graph, okay? This is something that is fairly new. It's been here for years now, but in the grand scheme of things, it's brand new, okay? So when we're looking at this, you're going to see a lot of these have the current year. What does that mean? That means it wasn't discovered until this year. That's the birth date of these things, when they see them, okay? And you're going to see most of them are closer to current than what they are way far back. Now, you're going to find a few like this one, 2003, right? Now, when we're talking about distance, they measure these things in lunar distance. What that means is the distance between us and the sun. No, I'm sorry, us and the moon. Duh. Anyway, lunar distance, that's how they do that. So if it's 3.1 lunar distance away, that means that you can go to the moon 3 times out past, and that's how far away this thing missed that. Now, I know you guys are probably thinking, man, that's a long way. Sorry, guys, I'm still getting over it. Sorry about that. Wow, I'm sorry. I tried to turn my head away from the speaker there. I couldn't get to the mute button fast enough. Sorry. Anyway, when we're talking about this is something that, in space, that's close. That's why they call them near-Earth objects, NEOs. But he's made a graph here, and you can go back a long way and see these. But most of what we look at are the ones that are close, what we would consider close. So when you see one that says 0.9, like this one, what's that mean? That means it's actually inside the distance to the moon. It's closer to us than the moon is. Okay? Hold on one second, guys. Oh, man, I thought I had that plugged in and I didn't. Boys, that could have been drastic. That could have been bad. That could have been bad. All right, there it is. Sorry. All right. Now I'm plugged back in. Probably might have even got a brighter picture there. Probably went dark on you there for a minute. Okay, so I'm plugged in now. Anyway, so, yeah. So that's what we're looking at. When stuff's 0.9, or if you see a 0 point whatever, that means it's closer to us than what the moon actually is. So kind of keep that in mind, all right? But yeah. So, see this one right here? BX1? That's the one that hit. What's it say? 0. I wanted to show you guys that because it's here. It's right here on this graph. So, yeah. So if you guys ever are curious on what if there's any asteroids, keep in mind, I always say this. Billy Bob Thornton said it in the movie Armageddon. What'd he say? He said, begging your pardon, Mr. President, but it's a big-ass sky, right? Ain't that what he said? he's like, well, why didn't we see this asteroid coming? Well, there's good reason for it. It's a it's a big sky. So and we're getting better at detecting them. But what they do here is this is a fireball report. So these are actually ones that probably make it into our atmosphere. And when they get here, they get burned up and they look like fireballs. Meteors, okay? Essentially. But that's, they actually have the all sky cam network. That's why that was put there. There's a network of cameras always looking up. They got these big fisheye lenses on them. And they were put there to detect these things. So they're global. They're everywhere across the planet. But I think they're moving to a different system on that, if I'm correct. If they're not, they need to, because those cameras, man, they're annotated for sure. Anyway, so let's go here. As you guys can see, guys, he's showing the same eruptions here. Okay? But guys, get over here and show Dr. Tony Phillips some love over at spaceweather.com. He just does such a great job, and he sends up weather balloons, and some of them he's lost. Had to go out like up into the mountains to get them, to try to find them, to get the data from them. So just kind of keep that in mind. Now, I want to show you this too. You're going to see, as these geomagnetic storms start hitting, the auroras are going to just explode, okay? So keep that in mind. If you're an aurora photographer, you already know this, promise. But if you're not, that's what they look for. But also here, guys, look, this is the day side of the planet, right? So when the flares happen, see, right there. That is the day side of the planet right now. So, but you see all this energy hanging around in our poles? That's why the radiation level was inching up, okay? Those protons got here. So you're seeing an X-ray flux elevated, all right? And it's probably going to continue. Again, I don't look for this thing to kind of get any slower or less intense. So I did want to show you guys that. So, but okay, so here's all your sunspots. I'm not going to go into detail on those today, but I just wanted to kind of get back on the horse here, guys. Latest observed R1, which means that this next data point is going to be up here. Okay, so we probably had another flare, which means we could have had another eruption. When you guys come over here to NOAA, this is what you're going to see. All these sites I just showed you guys, they're in my description box. The links are there. You guys can go down there and click on them if you want. I was putting all the people that I support in my description box, but I'm trying to put a featured channel section on my YouTube page itself. Most YouTubers have those anyway. So if you guys want to know who I watch and all that kind of stuff, you can go look at my subscription list. It's there. It's not private. I don't care. But I'm also going to have a featured channel list there, and I don't have everybody I'm putting on there yet. I just haven't had the time. But as we get moving forward, guys, I am going to fire up memberships probably here this coming week. Hopefully, you guys can help support me with that, just so we can all, have a place to come and just have a good, healthy thing. And again, guys, I'm monetized now, so if you want to super chat, you can. Don't ever feel obligated. But yeah, so that's what's happening there. And I'm going to get my widget put back on my OBS so I can highlight your guys' stuff. Okay, guys? So anyway, guys, I am going to pop off. If anything, like if we get into geomagnetic storm levels like big time, I'll come back on and I will definitely show you guys what's going on. If not, you will see me tomorrow. Trinity's probably going to be with me tomorrow at some point. If something happens and she can't, we'll move it out. But I'll definitely be letting you guys know that more solid answer. So, check, subscribe, share it out, guys. I want to get back into the algorithm. I said that last time before I got really sick, and I had some really, my life wasn't exactly what I thought it was since I was a kid. So I'm just going to leave it at that. Anyway, I'm not going to go into it. This was in a really bad place, and I had to handle some things. So anyway, I'm going to go ahead and get off here. I was kind of dealing with it on my own, you know. So just want to let you guys know, give you guys an explanation on what's going on. Didn't really have a whole lot of conversation with a whole lot of people about it, and but anyway, I will let you guys go, and I'll see you guys tomorrow. I'll be here tomorrow. I'm going to try to set a schedule, so it may be like a hard line here, but I'm going to try not keep it a hard line. We kind of give a 2-hour window when I'll be here. I'm not going to say, hey, I'm going to be here always at this exact time, because it never works out like that for me. My life is just really busy. So, but anyway, guys, God bless. Yahusha saves. You can drink this Kool-Aid.